Saxon Algebra Test 12. Number 1 is from Lesson 60, and it says a photograph is in the shape of a rectangle. It has a length of x plus 3 inches and a width of x minus 3 inches. What is the area? So we know that to find the area, we need to multiply the length times the width. So we have x plus 3 times x minus 3. Now, if you remember, this is the difference of squares. Both of these are an x and a 3, but one's plus, one's minus. So if you remember the shortcut, you know your answer is you take your first letter or number, which is x, and you square it, and then it's always minus. And then your second number, which is 3, but you square that, and it's 9. So that's your answer. However, if you didn't recognize that, then you can always FOIL. So remember, FOIL is first, outside, inside, last. So first is x times x, which is x squared. Outside is x times 3, or negative 3, so that's negative 3x. Inside is 3 times x, so that's 3x. And then last are your two last numbers, so 3 times negative 3, which is negative 9. Now if you notice, these two numbers in the middle, or two monomials in the middle, are like terms and we can combine them. However, one is minus, one's positive, so they actually just cancel out. So all we're left with is x squared minus 9, which is the same answer that we got up here. So just two different ways of looking at the problem. I'm skipping number 2 because it is an investigation. Number 3 is from lesson 53, and they want us to find the degree of the monomial. So if you remember, when we find the degree of a monomial, all we do is add up all the exponents of just the variables, not any of the coefficients. So if we look at just the variables, we have x to the third power, y, and since there's nothing there, we assume it's a 1, and then z to the fourth. So I'm just going to add up all of these exponents to get 8. So the degree of that monomial is 8. Number 4 is from lesson 58, and they want us to multiply. So we have to distribute the monomial that's on the outside into everything on the inside. So let's start with the first one, negative 3ab times 2a squared. So I multiply the coefficients, so that's negative 6. We have a to the first times a squared, so that's a third, because remember we add them when we multiply. And then we just have b. Now let's move on to our second monomial that we multiply by. So negative 3 times 4 is negative 12. Then we have a, and then we have b1 times b1, so that's b2. And then last but not least, we have negative 3 times a positive 3, so that's a negative 9. And we have a, b, and c. And that's it. That's your final answer. Number 5 is from lesson 51, and it says to simplify. So remember that radical expressions like this, or radical fractions, they're just like regular fractions. You need to make sure your denominators are the same. And if they are, then in your answer, the denominator doesn't change. Just like if you had, let's say, 3/4 plus 1/4. Your denominator doesn't change, you just change the numerator. Oops, that was wrong. You just change the numerator. So same thing with this problem. So the denominators are the same, so I'm just going to rewrite the denominator so I don't get confused and try to do anything different with that. And now if I look, I have negative 6 minus 8x. Now if I look, I have 6x minus 8x. So again, if it helps you, go and add the opposite, or add a line, change a sign. So you can see we have 6x plus a negative 8x. So that is going to be negative 2x. And that is our final answer. Number 6 is from lesson 46, and they want us to simplify this cubed root. So this 3 here lets us know that we're trying to find the number that multiplied by itself 3 times will give us 125. And if you don't know it off the top of your head, you might have to use some trial and error. But the answer is 5, because 5 times 5 times 5 is 125. So your answer is just 5. Number 7, they want us to simplify. Now, a lot of people are going to be tempted to go and maybe simplify this 6 and this 12 and make that 1/2, or the 3 and the 6 and make that 1/2. But remember, when you have a binomial like this, where they're being held together by an addition or a subtraction sign, you can't break those apart. So the first thing you always want to do is see if you can factor the numerator and the denominator. And we can. We can factor the numerator, because 3x squared plus 6x, we can pull out a 3x. And we are left with x plus 2. On the bottom, we can pull out a 6, and we're left with x plus 2. So now you can see these cancel, because they're exactly the same, it's just a form of 1. And then we can also reduce the 3 and the 6. So when we reduce that, we get 1x over 2, because I just divided 3 and 6 both by 3. And even more simplified is just x over 2, because you don't need to write that 1 in front of the x. And you might need to include your excluded values. And if so, remember we do that by taking our denominator, 6x plus 12, and setting that equal to 0. And then we just solve for x. Divide by 6. So this is our excluded value. X cannot be -2. Because if it were -2, it would make our denominator 0, which would make this an undefined problem. Number 8 is from lesson 39, and we just need to simplify this. So it's just a distributive problem. One thing I like to do is I like to go and make sure all of these negative exponents are positive before I start doing any multiplying. So remember, we make an exponent positive by moving it to the bottom if it was on the top, and moving it to the top if it were on the bottom. So this a -2, I'm going to move to the bottom. So we have a2 down there with the b, and we just have a 1 left up on top. Now inside, we have a, b, but I'm going to move that c -3 up to the top to make it a, b, c +3. And so that just means there's a 1 left over on the bottom. Plus, over here, I'm going to move that a -3 up to the top to make that positive. And then I still have this cb3, and then there's just a 1 left on the bottom. So now I can start multiplying this fraction to this one, and then to the next one. So let's start with our numerators. We have 1 times abc3. So that's just a, b, c to the 3rd, all over, and then we have a squared b times 1, which is a squared b. Plus, now we do it to this fraction. So again, if you're multiplying by 1, this is just not going to change, it just stays this. Same thing with the bottom, you're multiplying by 1, so this just stays a squared b. Now we need to go in and look if we can simplify anything. So remember, this a right here is really to the 1st, and that b is to the 1st. And so is this b. So I know that these b's are canceling out. And then if you look at my a's, I have 1 a on top and 2 a's on the bottom. So there's going to end up being, if you find the difference between the two, just 1 a, and it's going to stay on the bottom because there are more a's on the bottom. So this becomes a 1, and that's gone. Now let's look at our second one. We have a3 on the top, a squared on the bottom. So I find the difference between the two. 3 minus 2 is 1. And since there's more a's on the top, it stays up there, so that's now a to the first. C, there's only one c, so I don't have to worry about that. But I do have b third and then b to the first. So again, find the difference. 3 minus 1 is 2. And since there's more on top, it stays up there. So if I want to rewrite this answer, let me erase some of this so I can rewrite my answer. We have C3 over A plus A CB squared all over, well, there's nothing, so I'll just put a 1. And there's your final answer. Nothing more can be simplified. Number 9, from lesson 50, determine which of the values below are part of the solution set of the inequality 5 minus 2x is less than 9. So for these, you just need to take each one of these numbers and plug it into our inequality and see what makes it true. So let's start with our first one, negative 2. We have 5 minus 2. I'm going to plug in negative 2 for x is less than 9. That's 5. And then we have negative 2 times negative 2, so that's really just plus 4 is less than 9. Well, 9 is not less than 9, so I know that's not part of our solution set. Let's try negative 1. So 5 minus 2, negative 1 is less than 9. So we have 5 plus 2 is less than 9, or 7 is less than 9. That's true, so negative 1 works. Now let's try 0. 5 minus 2, 0 is less than 9. 5 minus 0 less than 9. So 5 is less than 9, so that works. So that one works. So probably all the rest of these are going to work, but on a test, I would still work them all out just to make sure. So we have 5 minus 2, we're going to plug in 1 is less than 9. 5 minus 2, 3 is less than 9. That works. So again, that one works. And let's do our last one, which is 5 minus 2 times 2 is less than 9. 5 minus 4 less than 9. 1 is less than 9. Oops, that worked. So we would say our solution set for this is negative 1, 0, 1, and 2. Number 10 is from lesson 57, and they want you to find the LCM, or the least common multiple, of 7, 8, and 10. So remember, we need to write out the prime factorization of each number. So you can use a factor tree to find these. I'm going to skip that step for now and just write out the prime factorization. 7 is 7, 8 is 2 times 2 times 2, 10 is 2 times 5. Now remember, you want to take every single number you see there, and then if there's duplicates of numbers, you just want to take them the most time you see them in a number. So notice that 10 and 8 both have a 2, but 8 has 3 of them. So in my answer, I'm going to have 3 2s. There's also a 5, so I have to include that. And there's a 7, so that has to be included also. So my final answer is, I know this is 8, and this is 35. So 8 times 35 is going to be 280. Number 11, what is the solution to the system of equations? So we could either graph these or we could use substitution. I'm probably just going to use substitution because notice they've both been solved for y. So I can just take, say, this problem that says y equals 4x minus 1 and plug it into this y. So I have 4x minus 1 equals 2x plus 1. So now I only have one variable, x, to solve for. So I'm going to get all my x's on the left side by subtracting 2x from the right and then subtract it from the 4x on the left. So I have 2x minus 1 equals, and then just a 1 over here, and then add 1 to both sides. So I have 2x equals 2, and then divide by 2. So I have x equals 1. So for part of my solution, I know my x value is 1. Now I need to find the y. So I'm going to erase this just to give me some more space to work with. So now I take either one of my original equations. I'm just going to take this bottom one, y equals 2x plus 1. Doesn't matter which one I choose though. And I'm going to plug 1 in for x and solve for y. So we have y equals 2 times 1 plus 1. So that's 2 plus 1. So y equals 3. And that is the solution to my equations. Now on a test, I would definitely want to double check this by plugging in 1 for x and 3 for y into each of those equations and making sure that it makes sense and it makes a true equation. So let's do it for the first one. So I'm going to do 3 for y equals 4 times 1 minus 1. So that's 3 equals 4 minus 1, or 3 equals 3. So that worked. Now let's do it with our second one. I have 3 equals 2 times 1 plus 1. So 3 equals 2 plus 1, or 3 equals 3. And again, that worked. So I know this was the correct answer. Number 12 says, determine the slope of the line that contains the points shown in the table. So remember, our formula or our method to find slope is to use this y2 minus y1 over x2 minus x1. So I really only need 2 points. They gave me 3, but I only need 2. So I'm just going to use these 2 points. So we have 0, 3, and 5, 11. So first I need to find the difference in my y's. So it doesn't matter which y I choose first, if I want to do 3 minus 11 or 11 minus 3. I'm going to do 11 minus 3 just to keep it positive. However, since I chose this y to start with, I have to choose this x to start with on the denominator. So now I find my difference in the x's, and that gives us 9 over 5. And since this is slope and we want to keep the rise and the run separate, I'm not going to change that to a mixed fraction, even though that's kind of what we're used to when we see something like this. So it just stays 9 over 5. Number 13 comes from lesson 47. It says a shoe store is having a sale of 25% off all boots. What is the discount and new price of a pair of boots that originally cost $95? So we're looking for 2 things here, the discount and the new price. So first let's find the discount. So we find the discount by asking ourselves, what is 25% of $95? That of in there means we need to multiply. So we're going to start by doing 95 times 25%, but I'm going to write it as 0.25 because we never multiply by a percent. We want to change it to a decimal. So that's 25. Bring up the 2. That's 47. And then 10, 19. So there is our discount. That is how much we get taken off of the price. So that's one part of our answer. Now we need to find the new price. So since this is a discount, we're taking it off the original price of $95, so we're subtracting what that discount was. So now we just do basic subtraction to figure out what our new price is going to be. So there is our new price, $71.25. You want to make sure you have both of these numbers for your answer. Number 14 comes from lesson 45. So we have 0.3 is greater than the sum of 1.2 and a number. So I'm going to start with 0.3 is greater than, so we want to use our greater than sign. And then it says the sum. That means I'm going to be adding two things. The sum of 1.2 and a number. So we have 1.2 and we're adding it to some number. And that's it. There's our inequality. Number 14 says, find the slope of the vertical line. So even if they gave us points, we don't really need them because you should know by now that a vertical line always has a slope of undefined. Now, just for some extra practice, if they wanted to know the slope of a horizontal line, it would be 0. So remember, vertical is always undefined and a horizontal line is always 0. Number 16, what number is 125% of 15? Now notice we're finding more than 100%, so I know my answer is going to be more than 15. So this is exactly the same thing as we did with like the 25% off the boots. So of means to multiply, so it's 125% times 15, but I'm going to write my percent as a decimal, so I moved my decimal to the left twice, and we multiply that by 15, and that's going to tell me what number is 125% of 15. So we'll just start multiplying. That's a 6. Then we have 5, 2, 1. 2 decimal places, so 1875. Okay, number 17 says a fruit stand sells 3 pounds of tomatoes for $2. Graph the relationship and use the graph to estimate the cost of 7 pounds of tomatoes. So we have 3 pounds of tomatoes is $2. So we have our X and Y chart. And we know 3 pounds is $2. So if I were to graph this, this would be our pounds, and then our cost over here, and our X and Y. So we know that, let's see if we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll go up to about 10. And let's go up to 1, 2, 3, 4, 5, 6. So we know that 3 pounds is $2. So therefore, if we doubled this, let's say someone got 6 pounds, it would cost $4. So let's go over to 6. We'll go up to the 4. And then we could keep going on by just, doubling this. But they want us to predict how much 7 pounds will be. So one thing we want to do is we could look at, this is actually very similar to example 5 on page 364 of your book. So let me just erase a little bit over here to give me some room. So we have 2 points. We have 3, 2. That's 1 point they gave us. We also found 6, 4. But we're trying to find y when x is 7. When we have 7 pounds, how much is it going to cost? So we're trying to find this. So one thing you can do is set up our proportion. So we could do y over x, so 2/3 equals, and then we're going to have y, because we don't know what that is yet, over 7. So remember proportions, we cross multiply and set those products equal to each other. So this is 14 equals 3y. If we divide both sides by 3, we get y equals, and that comes out to roughly about 4.666 continuing. So it just depends on where you want to round this to. If we rounded it to the nearest cent, it would be about $4.67. So for our answer, so we have, here's our graph, because that was one part. We had to graph first, and then we had to estimate the cost of 7 pounds. So we would say the cost is about $4.67. So those are your two answers, the graph and then this part. Number 18, the table shows the math test scores for 2 classes at a school. Does class A or class B have a greater range of scores for the math test? So we're looking for a range. Remember, that's the biggest minus the smallest. So let's just look at class A right now. It looks like 100 is their biggest number. And their smallest number, they're not in order right now, but if we look carefully, it looks like it is 58. So the range of class A is 100 minus 58, or 42. Now class B, their biggest number is 91, and their smallest is right next to it, actually 43. So 91 minus 43, and that will give us 48. So class B has the greater range. So class B, greater range, and that's your answer. Number 19, determine the slope and the y-intercept of the equation. So whenever they want the slope and the y-intercept, it's easiest to put it into slope-intercept form, which is y equals mx plus b, where m is our slope, and b is our y-intercept. So we have 3x plus 4y equals 12, and we're basically trying to solve for y. So that means I need to get rid of this 3x and move it to the right. So I have 4y equals negative 3x plus 12. Notice I'm starting to get it into this format. So I have my x and then my constant. So here's my x and then my constant. However, I have this 4 in front of the y, so I need to get rid of that by dividing by 4, which means I have to divide this whole side by 4. So everything on the other side needs to be divided by 4 also. So I get y equals negative 3/4 x plus 3. So the slope is negative 3/4, and the y-intercept is a positive 3. All right, last problem, number 20, is from lesson 52. It says Barry is selling baseball cards. He sold 2 for $7 and 3 for $10. What will Barry charge for 5 baseball cards if he keeps selling cards at the same rate? So when I see same rate, I know that usually means we need to find the slope. That's kind of what the slope is the rate of something increasing or decreasing. So they gave us 2 points right here to find the slope. We have 2, 7 and 3, 10. So the slope, we find our difference in our y's over the difference in the x, and that's 3/1, or just 3. So what we want to do is we want to create an equation for this situation. So we have a point, we actually have 2 points, and we have a slope. So we can use point-slope form to get us started on creating an equation. So I'm going to use this point right here, 2, 7, and my slope. I could have used 3, 10, but it doesn't matter, so I'm just going to choose 2, 7. So I'm going to erase this for right now so I can work over here. Now remember, point-slope form, we have y minus the y in our point equals our slope, and then x minus the x in our point. So let's simplify this now, and then we'll put it into slope-intercept form. So it's 3x minus 6. And then to put into slope-intercept form, we need y by itself. So that means I need to add this 7 over. So it cancels there, and I'm just left with y equals 3x plus 1. So here's an equation representing this situation. Now, we want to know how much will he charge for 5 baseball cards. So we have 5, and we want to know how much is he going to charge. So we're trying to find that y. So I can easily just do y equals 3, plug in 5, and see what the corresponding y is. So y equals 15 plus 1. So y equals 16. So for 5 baseball cards, he's going to charge $16.